This is lesson 9.3 in intermediate algebra, and the name of this is simplified form of radicals. So what we're going to be doing in this lesson is obviously simplifying radicals. So there's a couple properties we're going to look at right away, and then we'll do some examples. One is if we have an index of, let's say, 3, and we have two numbers or something, two letters, like 3, let's make it 3x. That is the same as the cubed root of 3 times the cubed root of x. You can split those up. So that means that if we have the square root of 4x squared, we can break that up to the square root of 4, square root of x squared, and then figure these out individually, and we get 2x. Now you'll get to where you can look at that and you'll be like, well, square root of 4 is 2, square root of x squared is x, and it's pretty easy to do in your head. Same way is true with addition. If I have the square root of that, that's the same as the square root of 9 over the square root of 2. Okay? So that's pretty much it for those two properties. And the next part is simplifying radicals. A lot of students enjoy doing simplification of radicals because they find that it's not too terribly difficult. And what I do when I teach this is I say, okay, if we just got a square root of a number, we're going to look for two factors of that number, two numbers that multiply that give me 50, where one of them I can take the square root of. Because I could take square root of 10 times the square root of 5. That doesn't simplify at all. But if I took the square root of 25 times the square root of 2, the square root of 25 is 5, and we put the square root of 2 on the end, and we get 5 square root of 2. And the way you can find out if you did this right is anything outside the square root sign we square, and we multiply by what's inside the square root sign. So 25 times 2 is 50, so I know it's correct. If I have the square root of 18, two numbers multiplied together give me 18. And one of them, I'm going to try to get one of them to be the square root. So then it becomes 3 square root of 2. If I have the square root of, let's say, 75, then that's going to be the square root of 25 times the square root of 3, which is 5 square root of 25, square root of 3. Okay? So that is a quick and easy way to do it. There are some times where you're going to run into some that are not so quick and easy. You may come up with some like square root of, let's say, 48. Now, are there two numbers multiplied together give you 48 where you can take the square root of one? Sure. 16 and 3 gives you 4 square root of 3. If you couldn't come up with a 16 and a 3, all you have to do is the factor tree. So we have 2 to the 4th power times 3 in here. Okay? And then we look at 2 to the 4th power, and that's 16 times 3. And we can take the square root of 16 and get 4, and we get 3. So we get the same answer using the factor tree, and sometimes that's the way to do it. But for the most part, you shouldn't have to do that very often, unless you get some really, really big numbers, weird numbers. Alright, so let's look at one like example 2. 48x to the 4th y cubed. I'm going to teach you a trick here, and I haven't taught this trick before, just because I hadn't thought of it. But what is the index in this? The index is 2. Alright, so let's look at the 48. We already said in the last problem that the square root of 48 was 4 square root of 3. Alright, now let's look at these numbers here. what I do is I find out how many times this number goes in that. Alright, and how many times it goes into it, tells me that that's the exponent on the x when I pull it out. That wasn't a very good explanation, so let me write 4 square root of 3. 2 goes into 4 twice, so that means I can pull the x out and put a 2 on it, because that's how many times it goes into it. Alright, now this is where it gets, maybe you can see it a little bit better. 2 goes into 3 one time with 1 left over. So the leftover stays in here. How many times it goes into it comes out here, and then we write it as 4x squared y square root of 3y for an answer. Alright, let's try another one and see if we can get this down, because it's really not that hard, it's just kind of new. Alright, cubed root of 40 a to the 5th b to the 4th. Okay, so we are going to split this up a little bit. And are there any factors of 40? Well, let's look at the factors of 40 using the factor tree. 220, 210, 5. And we're going to rewrite 40 as 2 cubed times 5, and then we'll do a to the 5th, b to the 4th. Okay. That makes it a little bit easier to go ahead and solve this. The book doesn't teach that, but I like to do that. I like to use that factor tree, because now I can look here and say, okay, how many times does 3 go into 3? Once. So I bring the 2 out, and I have an exponent of 1. That number there is how many times the 3 goes into 3, but I don't need to even show that. And I have a 5 here. Well, 3 does not go into the 1 here, so it just stays inside. Alright, how many times does 3 go into this 5? It goes into it once with 2 left over. How many times does this 3 go into this 4? Goes into it once with 1 left over. So my answer then is 2ab square root, or cubed root, sorry, of 5a squared b. Okay? So I'd like to look at a couple more before we go on. Square root of 12x to the 7th, y to the 6th. Alright, so I'm going to factor that down to 2 times 2 times 3, x to the 7th, y to the 6th. Okay, so there's a 2 there. How many times does 2 go into 2? 1 time. So I bring the 2 out and I put the 1 in it. There's no remainder, so the 1 disappears. 2 does not go into 1, so the 3 just stays there. 2 goes into 7 3 times with 1 left over. 2 goes into 6 3 times with nothing left over. So my answer is x cubed y cubed z. Oh, I'm sorry, that's a 2, isn't it? Put the 2 in front. Square root of what was left over. Okay, so that ends up being what I get there for 12x to the 7th y cubed. Okay, let's look at another one here, and we have the cubed root of 54 a to the 6th b squared c to the 4th. Okay, first step, break this down. Okay, so now I'm going to take my prime factors there, and we'll put them in here. We've got a 3 that appears 1, 2, 3 times. and then I write my a to the 6th, b squared, c to the 4th. Alright, let's move all this up, because that's all I've got left. Alright, so 3 goes into 3 one time. 2, 3 does not go into 2, so that 2 will stay in there. 3 goes into 6 twice, with no left over, so no a goes inside. 3 goes into 2, it doesn't, so we leave that in there. 3 goes into 4 one time with 1 left over. And we're done. That's it. Okay? That seems to be an easier way to do this than a lot of books teach, and it always works, so I'm not sure why nobody else teaches it. Maybe I just invented it, I don't know. Alright, so one of the things that's very important is you can never have a number on the bottom or a letter on the bottom with a radical, because that is the same as the square root of 3 over the square root of 4. We can never have a radical on the bottom, but when we take the square root of 4 we get a 2 and things are good. But when we get something like this, that equals the square root of 5 over the square root of 6. We cannot have a radical on the bottom. So what do? When we have a radical on the bottom, we multiply the top and bottom by that radical. So whatever the radical is, we multiply the top and the bottom by this. This gives me the square root of 30. This gives me the square root of 36. This answer you will always be able to take the square root of. And the square root of that will always be, just take the square root sign off of the original one, and you get your answer. Square root of 30 over 6. Alright, so let's keep looking at examples. This is example 8. And I think we're not going to get done in this video, so I'm going to stop this video here and do a 9.3b.